Hello, this morning I'm going to spend some time talking to you about Chapter 7 theory, and then I'll move into some of the stuff from Chapter 7s, how to compute some of the break-even, etc. But before I move into that, I just wanted to quickly review some of the, I think, really important concepts from Chapter 7. So the idea of Chapter 7 really is that process strategies allow companies to transform their resources into goods and services. And in class we talked about two separate, if you will, sort of diagrams, I guess. The first is what you see in front of you, this process, volume, and variety. And then the second is the service process matrix, and I'll get to that in just a second. Within this process, volume, and variety matrix, there's a couple things that are important. The first is these two lines. There's this line here that, of course, is the horizontal line, and this allows us to distinguish low volume from high volume. And this vertical line over here has to do with variety. So I want you to think of those in terms of production, both the volume that we produce and the variety with which we produce it. The key idea here is that there's a trade-off between variety and volume. And the more we produce of something, generally the less expensive we would like it to be. It isn't always a perfect trade-off, but ideally we get some quote-unquote economies of scale for producing more. That's why up here in this lower left corner we have a lower volume and a higher variety. Those types of manufacturing plants would be things that we often refer to as job shops. They have a process focus in that it is the process that sort of drives what happens inside of the shop. A couple examples we had from class was a tailor that might make a by hand suit. Another would be a place like maybe a shoe repair or a Kinko's copy shop where they have a whole variety of things they can do. It isn't exactly the cheapest possible way to do it, but what we trade off in cost we get from the variety. At the other end of the spectrum is down here, this product focus, and people often confuse these two, but the thing with a product focus is we've got the high volume and the low variety. Things that are made in a product focus are things like paper. Notice my picture here of a nice paper mill in Maine. Paper is something that we want to make for the lowest cost per inch or per sheet. So we invest a lot of money in equipment and we make it so that we can produce very high volumes. So it stands to reason that firms that compete down here with a product focus generally are cost leaders. Firms that compete up here are generally differentiators. I think the place that it gets confusing is, remember this, like many things in this class, is on a continuum. So right in here with this repetitive process, there are firms that compete more like cost leaders down here where they're sort of more competing on quantity, if you will, and not as much on distinctive things about the company. And then there are firms that are more up here, and those firms might be more like a differentiator, if you will. Mass customization is where we've got the high volume and the high variety. I suspect probably mostly on the differentiation side of things, but again, they're not going to be total differentiators because they're going to have to make enough to make it a profit. So that's kind of a basic review. One other thing was, in class I gave you an example for each of these, and I think I gave you an example for process and product, a product, paper, etc. Repetitive process, we often think of cars, so you'll see my Subaru car here. And then mass customization, I think I used Nike ID in class as sort of an example. A couple other things you could think of. If you want to take a look at the discussion questions, you'll notice that they ask you to to talk about the type of process for a variety of products. So beer would be probably a product focus or even continuous, which is something we talk a little bit in class. Wedding invitation would be a process focus or a job shop. That's this place up here, the one I talked about, like Kinko's, etc. Automobiles tend to be repetitive, and they have the modular piece that makes it that way. And paper would be continuous flow, of course, right? Like I showed you this little picture. And then a Big Mac, now we're talking more of a service, but it's a service with a manufactured piece, the Big Mac itself. So that would be more like a car. It's modular, repetitive, because there's only certain modifications one could make to their Big Mac sandwich. And then motorcycles would be as well modular, so those three fall in the modular. Yet custom homes, I think, would be more up here in the process focus. So that gives you a little bit of a rundown on the volume, variety, and how that works. This, what do you want to call it? Grid, if you will, to kind of understand where the things fit in there. Another thing we talked a little bit about in class was service blueprinting, and I just want to make sure you understand that service blueprinting is really nothing more than a method for service providers to consider looking at the various levels, 1, 2, and 3, the level that is the customer completely, then the customer interaction, and then the third level, the stuff you can do behind closed doors or away from the customer. So something like this video would be an example of such a thing. So here's my diagram of the service blueprint over here, and we've got the levels 1, 2, and 3, and we talked a little bit in class about it, and I just want to make sure everybody understands. They just need to know kind of basically about service blueprints. What I really want to talk though about is this service process matrix here. This service process matrix is important to understand that there are 4 quadrants here as well: mass service, professional service, service factory, and service shop. The vertical and horizontal axes, the vertical axis, the one going up and down, is degree of labor, and it is degree of labor essentially divided by capital investment. That's why airlines kind of fall down here, where it's a low degree of labor, and it's a low degree of labor relative to the total investment in pieces. The horizontal axis is the degree of customization. So up here in high, when we think about a professional service, a doctor, a lawyer, each thing is specifically targeted to a person or a situation. So it's useful to sort of summarize these, and I'll do that by saying, so a mass service would be one that has low interaction with the customers, a high higher intensity, so the degree of labor divided by capital investment would be higher than it would be in a service factory. A professional service has got the high interaction, the high customization, and the high labor intensity. And then down at the low end of degree of labor, the service factory, we've got the lower interaction customization, so we're not as customized, and we also have the low labor intensity. Like I said, remember, labor intensity is degree of labor divided by capital investment. And then service shop, we've got the high interaction and customization and the low labor intensity, so that's over here. So that gives you a good sort of summary of the service process matrix. Now I want to just switch over to the competitive advantage with respect to the service model. So if we think about the process focus for general purpose, there we'd probably be more inclined to be a differentiator. Whereas the repetitive focus, there we've got the quality going, and we could quite possibly be a differentiator, and that's what we would be looking for. But we could also be the response strategy up there with the mass customization, and the repetitive could be the response strategy or the differentiation. And then the product flow would be, of course, the low cost leader, or the cost leader as it's stated, and there we're trying to get the lowest cost per unit. So I hope that provides just a little summary of what we talked about in class the other day. So in front of you now you see break-even analysis, which you can find in your book on page 307. I suspect you have probably learned this before, so this is going to be relatively quick and, you know, designed to be just a review. Basically, the notion is we compute a break-even analysis when we are going to make a purchase and we know that the purchase is going to cost more perhaps than we are spending monthly on something, but we know it's going to pay itself back over time, so that's why we go down this path. So what I've done is made a little example here, and the example is basically comprised of, you know, things like this. So we want to compute the break-even in dollars or in units. We're going to need the price, we're going to need the number of units that we're going to sell or make or whatever. We're going to compute the total revenue, which of course is all the dollars that we collect versus you know, the net revenue, which would be the money after we pay for it. But nonetheless, TR represents total revenue. F would be the fixed cost. V would be the variable cost per unit, and then the total cost, which is going to be just a combination of the variable cost and the fixed cost together. So first, let's just take a look at this example that I've got down here. I'm going to roll up the screen here a little bit. So we've got fixed costs at $10,000, labor at $1.50, and material costs at 75 cents. And we sell this. So we go ahead then and put this in the equation, and we've got the fixed cost, which is $10,000, and we're going to divide by P minus VC. So P, we know, of course, is $4 minus the combination of $1.50 plus 75 cents. So 4 minus essentially $2.25 is going to give us $1.75 left over. We divide that into 10,000, and we end up with this 5,714. And this is 5,714.29 units that we need to sell in order to break even. Units to be sold to break even. So again, labeling our work, always really, really important. So I wrote it out here for you. So it's 5,714 units to be sold to break even. That's what that tells us. Now, if you were to look at the textbook, they would tell you that the way to compute the amount of dollars one must take in order to break even is this formula right here, or just below. So I'm going to go ahead and go through that formula, and then I'm also going to show you another way to do it. Either way is perfectly fine. So same idea, we're going to take the fixed cost, we're going to divide it by 1 minus the variable cost divided by the price. So we've got 1 minus $1.50 plus 75 divided by 4. And we end up with 10,000 divided by 0.4375. And when you calculate this out, you find out 22,857.24. And what is that? That is the number of dollars that we must make in order to break even. So I'm going to write that out for you in the same manner as I just wrote the other one. So you can see dollars in sales to break even, and it's this 22,857.24 dollars in sales to break even. So there we have two pretty straightforward break even problems. Now this next problem here, you'll notice I skipped a few, and that's part of what we're going to cut out because you know, we're running a little short on time in this section. So we're moving down here to this problem here, chapter 7.16, U-Crop's grocery store in Richmond, Virginia. They're going to open up a new line of kitchen tongs for supermarket distribution, and they estimate the fixed costs at facility A are going to be $5,000, and the variable costs are going to be $1.50 per unit. selling price is expected to be about $3 per unit. So we want to compute the break even in dollars, and we want to compute the profit if we sell 4,000 units, 9,000 units, and 12,000 units, and that's going to allow us to make this little graph. So that's why I wanted to do that. And then we want the switching point, which is the point at which it doesn't really matter which facility we choose, we're still going to make the same amount of profit. So let's first calculate the break even in dollars, in units, and then in dollars. And you might want to shut this off for a second and calculate this on your own, and just to make sure you know how to do it, because of course this we just did in the previous section. But I'm going to go ahead and calculate it for you here. We're going to first take the variable cost and divide it by the price minus the variable cost. So what we have is the fixed cost of $5,000, which we pulled right out of here. And we're going to divide by 3, which is the selling price of the tongs, minus $1.50, which is the variable cost. So we need to sell 3,333 units in order to break even. Now we're going to compute the break even in price, which is again going to be 5,000 divided by 1 minus $1.50 divided by 3, which is our variable cost divided by the price. So it's going to be $10,000. We can also, I told you I can show you one other way to calculate, to switch it from units to price. So you can do it this way, that's the way the book does it, or you can just take this and multiply it by the price. So in this case we'd be multiplying it by $3, and that should also equal 10,000, which it does. You can tell by seeing it. It's actually 9,999.999, but we'll go with 10,000. You know how I like to round. So it's the same. Either way gives you the same thing. Okay, now let's drop down here to calculating the profit if we sell these various amounts. So we've got a little bit different equation here. Profit is going to be comprised of price times X, the number of units we sell. That's what X is, the number of units that we sell. And we're going to then subtract off of that the cost. So we've got the fixed cost, the variable costs with respect to X. So if we want to make a profit, if we want to compute the profit at the first price break, which I believe was 1,000, then we're just going to put in here $3, because that's how much we get for each unit we sell. So we're going to do $3 times 1,000 units. So we're going to make $3,000, but we have to subtract off of it what it costs us to make it, of course. So we take 10,000, because, or excuse me, 5,000, because that's the fixed cost. So 5,000 plus variable costs times the number of units. So that's going to be the variable cost per unit's $1.50. So we're going to do 1.5 times our 1,000 units and this should be a loss of, so we're going to make that negative, $3,500. Oops, I got an extra dollar sign there. Let me just get rid of that, and I'm going to make it red because we don't want to forget that this is negative. So if we just sell 1,000 units, we're going to lose money. Now, let's go back up here for just 1 second and do sort of a sanity check. Of course, this says we have to sell 3,000 units, or 3,333, or else we're not going to even make a profit. So if you ever had a test question like this, you wouldn't need to even calculate this, because you know there will be no profit, because we don't even break even until we sell 3,333. So this next one here, we're going to do at 5,000, so we can just copy this. This is kind of a nice thing about doing it on a computer, I guess. And we're going to change this to 5,000. And now we don't have negative 3,500. Instead, we have positive 2,500. And we're going to change that from red to, of course, green, because that means positive, right? So now we're making a profit of $2,500. Now, what about if we were to sell 9,000 of these things? So we'll just put this here. And now we change this. We're going to sell 9,000. So now we're making 9,000 times $3. That's how much we're bringing in. But we have to subtract off of that our fixed costs and then our variable costs per unit. So we got 9,000 and times $1.50. And now we're not going to be in the red anymore. So we'll just change that to green. And we're going to make a profit of 8,500. Now, I didn't ask you to do this, but we could also do one more, right? We could do the profit, you know, if we sell even more of these things. So let's say the profit for maybe 12,000, just because the first one was negative, so you know it didn't really help us too much. So here we got $5,000.50, and then we got to change this to 12,000. And now we're going to make a profit of like 13,000. So that's even more. So clearly, the more we sell over 3,333, the more money we make. So this is in profit. Now, if we wanted to switch that over to units, if we want to make a profit of 2,500, we're going to sell 833 units, 8,500, we got 2,800 units, and 13,000, we got 4,300 units. I just divided 2,500 by 3 and 8, you know, similarly across the board. So now what we want to do is move on to this next question down here, because we want to look at what the switching point is to go from one to another. We can clearly see that if we sell less than 3,300 units, we're not making a profit at all. But we have these different processes. So here, if U Crops is enjoying an increasing demand of these tongs, and they're considering maybe relocating to a new facility where the fixed costs are going to be higher, but the variable costs are going to be lower, down to $1 from $1.50, what point then does it make sense for them to switch? What point of sales does it make sense for them to switch between the less expensive facility, facility A at 5,000, to the more expensive facility B at 7,500? So this is our equation right here. This is our switching point equation. We'll go ahead then and just plug the numbers in. Essentially, we're just going to be doing the same thing as we've done before. We're going to put in our numbers. So what I did was I just put the numbers in. So I got 5,000. That's the original fixed cost plus $1.50 times X, because we don't know how many units we need to sell. And then we're going to make that equal to 7,500, which is this new fixed cost, plus $1 times X. Again, we don't know what the X is going to be, but we want these two to equal. So if we sell 5,000 units, then it's worth it to switch to the second facility. So this number here represents the number of units that we need to sell in order to make it worthwhile to consider switching. This number represents the point at which we don't care either way. If we were to sell exactly 5,000 units from now until the end of time, well then we would only, then we could use either facility A or B. But because it says up here, U Crops is enjoying a consistently increasing demand, then when they start selling 5,000 units, we want to switch to the larger facility because it will be less expensive. And we can graphically depict this as well. But first I want to do is write out for you the interpretation of this 5,000. So the number 5,000 represents the number of units to be sold or sold at which it becomes worthwhile to switch between the less expensive $5,000 process, I think I wrote $5, but I meant $5,000 process, and the more expensive process of 7,500. So that's what this 5,000 right here is representing. I wonder if I can make that a color. Yep. The 5,000 represents the switching point. So what I did here was I went ahead then and plugged in the numbers for our little table here to see where it becomes less expensive between the two price breaks. So the way I set this up is, and your columns may be slightly different because I had to modify these. So we want to have the choices over here because we had the two different choices, choice A and B. The units sold, so this is 4,000 and 12,000, and then we have 4,000 and 12,000 again because essentially we have two choices. And then the variable costs with respect to the units sold. So since the variable costs for this first choice A, I'll just type it in here, are $1.50 per unit, and then choice B, of course, is $1 per unit. It's going to change the variable cost. So this one's 6,000. Our revenue will be the same, right? If we sell 4,000 units, we're going to make $12,000, whether it's for choice A or B. And then if we sell 12,000 units, we'll make $36,000. Again, the same for both A and B. What changes then is the profit, right? Because we're going to take the price times the units. So we're always going to make, this will always be the same, right? So in this case, it's going to be 12,000. It'll be 12,000 here because we sell the thing for the same amount. But what's different is this piece over here. So we sell and we know we're going to make $12,000 in revenue, but we have to pay for making the thing. So we have to pay our fixed cost, $5,000, and then we have to pay our variable cost, which is $1.50 times each unit that we sell. So in this case, 4,000. So what happens then is we end up with a profit of actually 1,000. I don't know why I have 12,000 there, but our total amount that we make is 12,000, but we have to back out 11,000. It gives us a profit of 1,000. Similarly, down here, we do exactly the same thing, but now we just change it to 12,000. We're going to sell 12,000 units. We're going to bring in, a substantial amount of money, $36,000, but we have to pay ourselves. We have to pay our fixed cost, $5,000, and we have to pay our variable cost. So we end up then making $13,000. Now we're on to choice B down here. So it's the same as this, except for this one, we have a little bit higher fixed cost. So our fixed costs change from up there, they were 5,000, now they're 7,500, and our variable costs are lower. But still, we're more profitable to go ahead and choose this option because we're not really selling enough to make it profitable. Now, when we get it up to 12,000 here, you can see we do indeed sell more. So we've calculated the point at which it becomes less expensive to go to the other one, right? We calculated that point out. But we're going to also, we make this table. This enables us then to graph it. And we ought to be able to see the point at which it becomes less expensive to switch to the other one. Now, like I said, we already calculated this, and we already know what our switching point is from the previous calculations that we did. But we want to graphically depict that. So what I've done here is created a grid so I can graph this for you. So I deleted the squares that are on your page, but you're going to be doing it by hand, and I have to do it on this computer, and I can't make it show. This goes 1,000, 5,000, 10,000, then it shows 15,000 here, but you can't really see that, so just trust me. And then this is units down here, so we have 4,000, 6,000, etc. So what I'm going to do then is draw on here kind of the way the lines work. So first thing is with option number A, or option A, we go back up here and we want to graph the point, the units sold and the profit, right? So at 4,000 units we have a profit of 1,000, and at 12,000 units we have a profit of 13,000. So we go down here and we're going to make essentially 2 points. So we're going to have a point right here between 1,000 and 4,000, so right about there, and then we're going to have another one between the larger amount of 12,000 units sold, which is going to be way over here, and the profit, which is going to be 13,000, which will be right up here. So I'm going to go ahead and graph that. Okay, so what I've tried to do here, as best I am able with the computer, is to graph the two different lines. So this first line with the triangles here, this is the least expensive fixed cost. So there, when we sell just 4,000 units, we make a profit of 1,000. So that's what this triangle here represents, is this profit of about 1,000. And we're selling about 4,000 units. This is slightly off, but you get the idea. Then when we sell 12,000 units up here, we make then a profit of between 10 and 15,000, actually 13,000, and that's kind of what this represents here. That's that profit point. Over here, the red line, you see, first of all, the first point, which is when we sell 4,000 units, we make a profit of 500, which is sort of below your diagram here, so you can't really see it, but trust me, it's down there. Then it goes up to units. When we sell 12,000, we make a profit of about 16,000, so it's up here. The point at which these switch, we know already from our previous calculations, about 5,000 units. So I've annotated that with this, the green line, if you will. So we can see that we go from one to the other at this point here. So hopefully this makes some sense to you, and you should be able to do the problems similar to this in your textbook. And let me just give you a list of those here quickly. So problems like these would be found in chapter 7, and they'd be 7, 9, 7, 10, 7, 11. Oops, I'm sorry. And there are others as well, but certainly, you know, if you practiced a few of these, I think you'd be fine. Keep in mind that I skipped over the design, capacity, and effective utilization and that sort of stuff. Essentially, I think it's page 3 that I sort of just skipped completely over. So this concludes this video about chapter 7 and break-even analysis and sort of a basic understanding of it all. Again, I welcome your feedback on this. If it's helpful, if I could make it better by, I don't know what, but doing whatever. And of course, if anybody has any skills in doing this and they want to share them with me, I'd be thrilled to learn them. So again, thank you very much. Have a great day. Hope this helps.